This is going to be page number 69. All right. So, as a recap of yesterday, right, we spent time learning about angles, formalizing angles. We knew intuitively what an acute angle is, an obtuse angle, straight angles. We knew what those were, but we needed to formalize this with some language to make sure that we're all commonly understood and we can use angles in a valuable way. What we're going to talk about today, though, is this kind of interesting topic. It's a subtopic or a little mini lesson category thing when we're talking about these angles, and it's this. Sometimes we have special angle pairs, okay? If I have two angles, there's a lot of things I can say, and so I want to kind of start with this. The first of our special kinds of angle pairs, we're going to take two angles, and if they are lined up on top of each other, then they are called adjacent angles, right? When I think of the word adjacent, I think nearby, right? So I'm going to kind of write this here. Adjacent is kind of like nearby. They're close. In fact, they're literally on top of each other. They are two angles that they lie in the same plane, okay? They're two angles that lie on the same plane. They have a common vertex that they're both sharing, right? And a common side, but they don't have really any common interior points. That's kind of the thing about it. For example, if I look here, you see how I have angles 1 and 2 where they're like right on top of each other, but neither of those angles share any of the same points, right? Like F and H are not on, like inside of the same angles. They're on inside of different angles. Versus this example here where it's talking about there's two angles, but they're not directly on top of each other. They're not nearby enough, okay? So that's the first kind of special angle pair, is something called an adjacent angle. So what questions do you guys have about how we can label or look at adjacent angles? What is, what isn't an adjacent angle? Okay. And what this leads to is probably one of the most useful to us kinds of special angle pairs, okay? See, adjacent angles is kind of more just a general term. Like it's kind of like I have lots of fish out there in the ocean. It's very general, it's very broad. There's a lot of different like adjacent angles that we could talk about. To be more specific though, linear pairs are very useful to us. It is a very useful thing. This would be one that's important, that we really understand, okay? A linear pair is a pair of adjacent angles, okay, where we have a pair of opposite rays, okay? I want to make sure that's very specific. You see how, if I'm looking at this example here, 1 and 2, I have these two angles that we know that that's adjacent. They're adjacent angles like we just saw. But we notice also we have that two of those rays, two of the sides of our angles, form opposite rays. They make a straight angle. And how many degrees is a straight angle? 180, exactly. So what that's saying is, oh, wait a minute. What's so useful about a linear pair is that their measurements add to how many degrees? I'll ask that again. The two angles, they're adjacent, but if they are a linear pair, what do their measurements add up to? 180. That's what's useful, is if we know that it's a linear pair, we have a number we can associate with it. That becomes very useful when we solve problems using linear pairs, okay? And so that's what makes this special. We know that the sum of the angle measurements, that's what this part right here is saying. The sum of the angle measurements is 180 degrees of a linear pair. Okay? We will be able to look at this and use this as evidence to be able to prove some theorems as we go into this proofs unit, okay? So I want to make sure we spend enough time giving the importance of this idea. This will be a very useful and important idea. So what questions do you guys have about linear pairs and how they work? They aren't a linear pair unless we have a pair of opposite rays. Okay, that's the important thing, is if I look at this example here, yes, this is a pair of adjacent angles, but I don't have an opposite ray that I can leverage to make 180 degrees. Okay. Now the third kind of these weird special angle pairs is this, another very important thing, okay? A very, very important thing. We're going to use this one maybe even more than linear pairs, okay? They're building off of each other. And it's this, vertical angles. We're not supposed to do gang signs in school, I'm pretty sure, but here's what I'm going to do. You ready for this? I'm going to take my fingers. I'm going to do like the Richard Nixon thing where I'm like, I'm not a crook or whatever. And I'm going to like do this. Like gang sign, I guess, right? Right? Okay? Okay? Because, see, with my fingers, I'm making like what, the letter V right here? Like each of these is like a V. Like V for vertical. Okay? And I'm going to line them up kind of like I'm doing a weird gang sign thing. Notice that the common endpoint, right, the vertex, is like stacked on top of each other. You see that? It's like two V's where they share a vertex. If we're looking here, right, vertical angles are two angles that are not adjacent to each other. Okay, so they aren't stacked on top of each other this time. However, because they have to be like perfect V's, they are made when I have two lines that intersect each other. So if I have two lines that intersect each other, vertical angles are the angles that I make with my gang sign. Okay? Or in other words, the opposites across. Not the adjacent ones, not the ones that are like stacked on top, but the opposites. So like, for example, 1 and 3, angle 1 and angle 3 here. I have two lines that intersect, and they are like opposites across where they have that V shape. Okay? Those are called vertical angles, right? V for vertical, that's what they are. And here's the very special property associated with vertical angles. Make sure that you understand this. Vertical angles are congruent. Okay? Vertical angles are always congruent. If I have two lines that intersect each other, not two opposite rays every time, but if I'm thinking about it, right, I have two angles that are opposites, those are vertical angles, that automatically tells me that their measurements are equal. Or in other words, those angles are congruent to each other. Okay? When we write that, when we want to indicate that, what we do is we draw a tiny little curve. If you look at this example right here, 1, 2, 3, and 4. See how 2 and 4 are vertical angles to each other? We know that they're vertical angles to each other. Well, we're going to say that they're congruent to each other, but each of them, you see how I have a little like curve or like arch? Well, both of those angles, how many arches do 2 and 4 have? 1 each, exactly, 1 each. Compared to 1 and 3, how many arches do 1 and 3 have each? 2. What that tells you is that 1 and 3 are congruent. 2 and 4 are also congruent. but 1 and 2 are not congruent to each other. Okay? The number of arches tells you which angles are congruent, which ones match up. How do they correspond? So 1 and 2 are not congruent, but 1 and 3 are. 2 and 4 are congruent, but 2 and 3 are not. Okay? That's what those arches are telling you. So, what questions do you have about any of these special angle pairs? Okay. As you guys are writing that, I'm going to flip the page. We're just going to do one problem kind of example together. Okay? And then I will get you going on the check your understanding stuff. So, let's kind of break this down. It says, if we're looking here, this is on page 70 if you want to follow along. It says that we have some weird looking office lamp. Okay? And it's made using 2 intersecting metal bars. It's kind of like one of those weird like duck things where it's like you have a little pool of water and it like bobs its head and then like drinks the water and then like bobs back up, kind of like that. First it says this. It says, how many pairs of adjacent angles do we have? It says list 2, but let's think about how many different ones we have. You guys tell me. How many different adjacent angle pairs do we have? What is your guys' guess? How many? How many adjacent angle pairs do we have? Four. Yeah. So if we think about it, adjacent angles are just 2 angles that are stacked on top of each other that are like next to each other. Okay. So we have angle ABE. There's one of them. And notice how that's paired up with CBE. You see how those form 2 adjacent angles right here? So there's one pair. And then you guys notice there's a second pair. There's a third. And there's our fourth. Right? If we have 2 lines that intersect, they will have 4. So if we want to list 2 of the pairs, we could say, well, angle what? What is our first pair we want to go with? I guess we could go with what? ABE and EBC. Yeah, totally. EBC. And then let's do another one. What's one more pair we could come up with? Okay, yeah, CBD, right? And then ABD, yeah. And ABD, absolutely. So now it asks this, identify 2 pairs of vertical angles, right? Using our gang signs here, are 2 pairs of vertical angles. We're looking for the opposites across the endpoints. Yeah, that's our first one. So we have ABE and DBC. Angle DBC. And then what's our other pair that we don't have yet? So if we have angle EBC and angle ABD. To make it clear what we're talking about here, here's one of our pairs of vertical angles, right? I use that little arch, that little curve, to say that that's congruent. And then here's my other pair. I'm going to use two arches this time. They're just opposites across that endpoint that they share, that vertex. Part C says, how many linear pairs do I see in the figure? Right? Linear pair as in adjacent angles that add up to 180. How many adjacent angle pairs do I have that add up to 180 here? Maybe think a little bit more. See how many more you can find. Four. Yeah. Each of these adjacent angles here is going to be a linear pair. How do I know that? Not just because I said so, but how do I know that each of these adjacent angle pairs is going to be a linear pair? They do add up to 180. What tells me that? They're straight lines, or they're also just opposite rays. Either way works, right? It's the same sort of thing. So how many do I see? Yeah, there's 4. And if it says list each, it's just asking us to list each of those pairs. We're not going to list all of them, but we could say like angle ABE and angle CBE, right? ABE, CBE. They're going to add up to 180 degrees when we add up their angle measurements. And you could probably go ahead and list all of them if you wanted to. But for the sake of time, we need to find the measurement of EBC. So find EBC. How many degrees is that? $138. How did you get 138? Exactly. If they're a pair of vertical pairs, what do we know about vertical pairs? They're congruent. And so that tells me if, what, angle ABD, right? If that's 138 degrees, well, then the vertical pairs, that's congruent. So we know that the measure of angle EBC is equal to 138 degrees. They're congruent. And using the definitions still, how would we find the measure of ABE? $42. How in the world did you come up with the meaning of life right there? 42. Exactly. We know that it's a linear pair, right? We have a linear pair, there's adjacent angles that add to 180. And one of those pieces is 138. So we're going to take 180 minus that 138, and that gives us the missing piece, right? So the measure of angle ABE is 42 degrees. So what questions do you guys have about adjacent angles, linear pairs, or vertical angles? Okay. I'm going to go ahead and pass this out to you guys. This is just to check your understanding. We've got about 9 minutes to be working on this. It leverages all of the vertical angles, linear pairs, as well as how we determine the amount of your angle measurement from those things. If you have two lines that intersect, you have 4 pairs of linear pairs, and you have 2 pairs of vertical angles. You have a vertical pair.